In 6.3, we're going to be dealing with 3 different theorems that we can use. And the first one kind of has a funny name to it. I thought it was kind of a joke because it's a side splitter. For those of you who haven't, I laughed so hard my sides hurt. That's a side splitter, kind of a joke kind of thing. So that's what I wrote. Anyhow, the side splitter theorem says if there's a line that goes through a triangle and it is parallel to the side of a triangle, then it divides those sides proportionally, meaning that if I cut this triangle and these are parallel, then this over that will equal this over that. It only works for the sides. And I have to say that because so many students get this confused with what we did before. What we did before is if we deal with anything that deals with the bottom, the RS and the XY, then we would have to add the sides together to get to a full side. But if this is parallel to that, we can do this side over this side equals this side over this side. We can do those proportions. Keep that in mind. Sides are different than the bottom. I need to say that. The corollary to it is what if it's not a triangle? What if it's a bunch of parallel lines and you have a transversal and another transversal? Well, if they're parallel, they will be in proportion to each other. AB over BC will equal WX over XY. They will be in proportion to each other. They will be able to simplify. And the last one, if you have an angle bisector of a side, that angle bisector will cut it up into proportional pieces. So what I can do is I can say the left side of the angle bisector and then the bottom of the angle bisector is going to be equal to the right side of the angle bisector over the bottom of the angle bisector. And so we're going to use these 3 sets of proportions to solve all the problems on this worksheet. The other thing that I need to warn you about is basically a hint. If you see a full distance, if there is like a blue arrow, if you see a full distance on a side length, you're going to need to use subtraction in order to get the correct side lengths. They're trying to trick you basically. So if you ever see a full distance, keep in mind that you're probably going to have to do some bit of subtraction to figure out an individual side length. I say that and you'll see what I mean when we get to some of these examples. Here's number 3 on your worksheet. Find the missing side length. They are trying to trick you on number 3 because they gave you this full distance 12. You are not going to use the full distance 12. You will use it. But if I want to know, and I know that this is, let's go over here, grab my pen. This distance is 2, and the full distance is 12. How long is this piece right here? This side. So since that is 10, I can now use the side splitter theorem. Why can I use the side splitter? Because these 2 are parallel, and I can do this side over this side equals this side over this side. Well, you can call this whatever you want to. You can call it a question mark. You can call it X. Let's figure out what that question mark is. Let's use the side splitter. X over 15 should be equal to the 2 over the 10. The way they're trying to trick you is they give you the 12. They want to see if you're going to mess up the proportion. For the side splitter theorem to work, you have to use sides. Little side, little side. Let's cross multiply. X times 10. 2 times 15 is 30. Divide by 10. Has to be 3. Is that what you got? On your worksheet, it doesn't come out blue. On your worksheet, you're not. Anytime they use these little arrows, keep in mind they are going to be trying to trick you on those ones. The other ones are pretty much straightforward. Let's look at number 4. This looks like a side-splitter theorem. The only issue with it is they gave me one of these arrow things again. I have this side, which is 3x minus 5. I have this side, which is 10. I have an 8, but they give me the full length of the 28. So before I can use the side-splitter theorem, I got to figure out what this distance is here that I just highlighted in red. How long is it? The reason why I do that is so that I have a side and a side and a side and a side. Now I can use the side-splitter theorem. I can do 20 over 8. 20 over 8 equals 3x minus 5 over 10. The reason I chose number 4 was because some of you might forget about this 3x minus 5. When you do 8 multiplying by the 3x minus 5, that's in parentheses. You have to multiply this 8 to the whole group. So when I write it, I usually will put it in parentheses so I don't forget to distribute. The number one mistake that students make is they forget to do the 8 times that negative 5. 8 times negative 5 is negative 40. 8 times 3x is 24x. Most students get the 20 times 10 correct, and they get the 200. You add 40. Divide by 24. And they're being really nice to us because that just goes in nice and easy. X is 10. 2 more examples. Number 7 is the next one. This is the angle bisector theorem. I know it's the angle bisector because I have 2 angles that are equal to each other. If these 2 angles are equal to each other, then this is an angle bisector. If this is an angle bisector, then the right side and the left side are going to be in proportion to each other. And it doesn't matter which one you pick as long as you follow the same order. Here's what I mean. You can do 30 over 15 or you can do 15 over 30. It doesn't matter. You pick which one. Let's say you pick 15 over 30 though. As soon as you pick your proportion, you have a direction. The other side now matters. If I did this top side over the right, then for it to be equal, I have to make sure it matches 21 over x over our missing question mark. So the direction does matter once you pick your first one. After that, cross multiply like we've been doing. 15 times x equals 30 times 21. I don't know what that is. I'm going to use my calculator. And then I'm going to divide by 15. Once again, that's a little bit big, so I'm going to use a calculator for it. I'm getting that it's 42. And it's 15. This 30 is bigger. 21, so I need to be bigger than that. So that kind of makes sense. I like to always see if my answer makes sense. It does. Last example. Number 11. I picked number 11 because it had multiple x's, just in case. So I look and I see these 2 are parallel, and I have a side and another side and another side. So I could use the side-splitter theorem. I could use whichever side I want to first. Let's just make it look like it's set up. Let's do this side over this side. 12 minus x over x plus 3. And that should be equal to the other side, top over bottom. We're going in the same direction when we set up our proportion. The mistake that I normally see, don't forget to distribute this 4 to both of these things. It's 4 multiplied by the 12 minus x. It's 6 multiplied by both of these things, the x plus 3. So a lot of times I will write these in parentheses and then distribute 48 minus 4x, 6x plus 18. And this worksheet, once again, when you do things right on this worksheet, everything's been coming out nice and even. I'm going to stop your notes right there.